Well, welcome back to our mini review topic. Tonight's topic is called implicit differentiation. So let's just quickly review what we mean by the word implicit. For example, an explicit equation looks like y equals x squared plus 4. I'm explicitly solved for the letter y. An implicit equation is something that I can't solve for y exactly. Say x squared y cubed plus 2yx equals 4y squared. Something to that effect where I can't easily solve for y. So we say that's an implicit equation. So just a quick review. When I take the derivative, I'm taking the derivative with respect to x. So let's make a note. We want to derive with respect to x. So for example, if I was taking the derivative of y, I would say its derivative is dy dx. If I was taking the derivative of p, I would say its derivative is dp dx. I'm taking everybody's derivative with respect to x. Therefore, the derivative of x itself is just 1 because it already has x in the problem. Alright, so here's our first example of an implicit differentiation. I can't stress enough, before you take the derivative, read out loud. Okay, this says x squared, what y? Hopefully you're saying the word times. Therefore, that should be screaming product rule at you. This says 2x times y. Notice when I say times, I'm not doing it between a constant and a variable. It's just between the two variables. So I'm saying it's negative 2x times y. All right, so let's walk through product rule one time together. So I'm going to say it's the first derivative of the second. So that's my first term. Here's my second term. That's dy dx, derivative with respect to x, plus the second term, derivative of the first, should be 2x. Now, I'm going to leave this negative 2 out front, and I'm going to bracket everything in here. And that's just a personal preference. I like to leave the constant out front and just do the product rule between the variables. So my product rule is between the x and the y. So I'm saying first derivative of the second plus the second derivative of the first. And then, of course, equals the derivative of negative 2 should be 0. All right, cleaning up, I'm just going to say that's x squared dy dx plus, just put these alphabetically, 2xy. Now make sure you take this negative 2 that you left out front and distribute. That's why I had those brackets there. Negative 2x dy dx minus 2y equals 0. At this point, my goal is to get the dy dx's on one side. So I'm going to leave those there, and I'm going to boot the other two to the other side. So I've got x squared dy dx minus 2x dy dx equals, I'm going to add over the 2y and subtract the 2xy over. And then, of course, you're just factoring out dy dx. You're pulling it out as a GCF. I've got x squared minus 2x. And finally, dy dx equals 2y minus 2xy all over x squared minus 2x. Now I want to remind you, there's an equivalent answer. You could have the complete opposite sign. Notice this is positive and this is negative, so the complete opposite would be negative 2y plus 2xy all over, this x squared was positive, this was negative, so I would say negative x squared plus 2x. Just make sure it's the complete opposite, and those two are equivalent to each other. All right, number 2, x sine of y equals 3y plus cos of 2x. Now, notice when I read that again, I'm going to put parentheses around here. That's x sine of y, and that was times, so I'm going to put my times sign in there, equals 3y plus the cosine of 2x. Every time you say of, you should be putting your own parenthesis in. So again, this is x times sine y. Those are two variables that I'm multiplying, so that's product rule. 3y, not product rule, because 3 is a constant, not a variable. Cosine of 2x would be chain rule, taking the derivative of something. All right, pause it, try it on your own. I'll just compare our first line. All I want you to do is get the first line right, and we'll just make sure we're at the same place before we move further. So pause it, try it on your own. All right, there's lots of little things. So there's my first. The derivative of sine y is the cosine of y, but notice that's the inside. So the derivative of y should be dy dx. Plus sine y, the derivative of x is 1. 3 times y? Well, if it was 3x, the answer would be 3, but the derivative of y should be dy dx. I've got a nice chain rule. The derivative of cosine should be negative sine of 2x times 2. So pay close attention to those details. Now, notice that this dy dx is attached to this term, so this whole term stays, and this dy dx is attached to that term. So I need those on the same side, everybody else to the other side. So hopefully your row looks like mine does. And then again, I'm going to factor out, I'm going to pull out my GCF of dy dx. So I've got x cos y minus 3 equals that same junk. And I'm going to divide this to the other side. So I know I left that row out there, but hopefully you're getting the same answer. dy dx equals negative sine of y minus 2 sine of 2x all over x cosine of y minus 3. Now remember, you could have that complete opposite. And basically, if I don't see this as my choice, hopefully I'm seeing the complete opposite. The positive sine of y plus 2 sine of 2x all over 3 minus x cos y. And of course, I just reversed the order there. All right, let's try another one. All right, so these are getting a little uglier as we go. Number 3, the sine of xy equals the quantity x squared plus 4 to the 5th. All right, read this again to yourself. The sine of, what does it actually say in here? X times y. So there's my product rule here. Equals, this is clearly chain rule. So pause it, try it on your own. Hopefully you can nail that derivative. That should be the easy part, and then we'll clean it up. All right, so the derivative of sine should be cosine. Keep the inside. Now, if you read that inside, it said x times y, so you've got product rule. First derivative of the second plus second derivative of the first. Now here's my chain rule. Bring the 5 down, keep the inside to the 4th. Derivative of the inside should be 2x. Now at this point, did you catch that this is basically like a coefficient? It's this times something with a plus sign. Let me break it down easier for you. If I said 4 times x plus y, would that be a no-brainer what to do with that 4? I think you would just take that 4 and distribute it through. Well, basically it's the same thing. It's just uglier. It's not a pretty 4. It's the cosine of xy, and I know I'm distributing because of this plus sign. So I'm just going to take that and distribute it through. So I've got the cosine of xy, and then I have that times x dy dx, plus the cosine of xy times just y, equals, and I can multiply this 5 and 2x together because they're not raised to any power. So I'm going to say 10x times x squared plus 4 to the 4th. All right, remember, my goal is to get this dy dx by itself. So I'm going to subtract this to the other side. So I've got the cosine of xy, x dy dx. So I'm subtracting that cosine of xy times y over. And then to get this dy dx by itself, I'm basically just going to divide both sides by x cosine of xy. And there you have it. dy dx is equal to this lovely term here. All right, next question. This time we're asked to find the second derivative. So I know it's the second derivative because obviously I see all these 2's, and that's implying second derivative. Now you can't get to the second derivative, of course, without taking the first derivative. So let's just slow down and get the first derivative. Again, read it out loud. 2x to the 5th, nothing fancy, but this clearly says x times y. So we've got product rule there. So pause it, try it on your own, solve for dy dx. All right, so you can quickly take a look at mine. I've got 10x, first derivative of the second, plus second derivative of the first, subtracted my y over, divided by x. Bam, we've got our dy dx. All right, so box that in. Let's just be clear. This is the first derivative. All right, so this is what I get for dy dx. Now, in order to get the second derivative, I need to take this guy's derivative. So as I read through it, you can basically do it two different ways. Because there's one term on the bottom, you can make like a beaver and split. So that's one option. Or you can just go quotient rule. And I'm going to go quotient rule. I kind of prefer that for these second derivatives. So I'm going to go low d high, the derivative of 10x, of course, is 10, minus the derivative of y is dy dx. Low d high minus high. D low is just 1 all over low squared. Now the neater you write is typically, the easier it is to solve this problem. I'm going to go ahead and I'm going to take this x and multiply it through here. So I've got 10x minus x times dy dx, which I'm going to leave blank for a moment, minus 10x plus y all over x squared. So I just want to be clear, I also took this negative and distributed it. That's how I got the negative 10x plus y. Now, I left this blank dy dx here because remember, we know what dy dx is. We solved for that. That was the first thing we got. So in place of dy dx, I'm really putting 10x minus y all over x. Okay? So you're always going to use that first derivative when you do a second derivative. And as I clean that up, this is really 10x. Of course, these x's are going to cancel. And again, make sure you take this negative and distribute it through. So I'm getting minus 10x plus y minus 10x plus y all over x squared. And as I clean that up, the 10x minus 10x cancel, and that looks like 2y minus 10x over x squared is equal to my second derivative. And there you have it, day 1 of implicits. We are going to spend one more day tomorrow talking about implicits, focusing more on the vertical and horizontal tangent lines. Well, hope that was a piece of cake, and we'll see you in class tomorrow.